Hello. For this part, I will introduce the functionality of our Nano Twitter. First, let's type the URL into the browser. So let's log out this account. So if you are not logged in, you will see recent tweets posted in this website. So there are several tweets. And for non-logged in user, you can search tweet like if we type HI, then the website will show you the result of HI. And also we can search user like we type H. We can see the user's username contain H will show out. Next, let's sign up. Create a new account. Its username is new sign up now. Yeah, we have logged in. So we can tweet a tweet like type hello and click my tweets, then it will show you all tweets that you tweet. And also we can edit our profile, like we can add its birthday and change its nickname and add some description. Submit. Okay. Also we can follow other users. Click followings. So there are some user recommend to a user, so let's click following. Also we can search user if you know the user's name, like type there then Dragon Cell. So we follow the Dragon Cell, then come back to our home page. So there are several tweets tweeted by our followings, and we add other functionalities like likes. If we like a tweet, then in our likes, it will show the tweets that the user likes, and what's more, in our notification bar, you can see the notification that I like a new tweet. Also, if some users followed this new, let's try that. Log out the user and log in another account. Dragon cell and sign in and search the user like NU. Yeah, just follow him. Then we log out, sign in the NU user, new, and see there there is one notification that tells NU user that Dragon Cell has followed him. Also, we use the Redis to increase our response time to record the homepage, non-login time, and tweets, and the user's information. And that's all. If you are interested to our website, you can explore more.
Hello everyone, this is Zhadong Yan. I will go through our codes quickly for you. First, this is our API directory, which includes test APIs and tweet APIs and user APIs. Test APIs are for the seed. We can set standard seed by this code, and we can have a flag user to show if the seed procedure is done or not. Then this is our configuration directory, which contains some important configurations such as database schema, database adapter, and some initializers such as Redis. And this is our database directory, which contains our database schema and the structure of each table. We have some index for this in order to speed up the query time. And this design directory is our sketch for the UI design. The doc directory contains our previous schema, and the final team schema is this one. Lib is just one of the useful tools of our NetTeacher. Models are important basic models, classes of different users, tweets, likes, hashtags, for etc. They are all active record-oriented. And public directory is used for put some public information such as loader keys and some CSS. And service directory contains our major services such as notification, search, timeline, and tweet. And update Redis is a very important service which would update the Redis of different users' tweets and their user informations and their follow relations. By doing so, our service will be a lot quicker. And style sheets is a single CSS for a single user. Test directory is for our mini tests designed for different APIs. View directory contains our ERBs, which are important UI views, such as home, index, and we have a layout that contains some CDNs, which will speed up the response time if you use Google. And app.rb is our main entry of the project. You can see some basic URLs such as the index, sign up, sign in, sign out. And this Ruby is just for reset the non-login timeline. And this is our configuration. Some gem file license is just MIT license. We have proc file, rec file, and readme. The version is 1.0. Thank you.
I'm Xinyi. I'm going to talk about what we do in the scalability problem. And so this is the test result of the original configuration. We use the web brick as web server, and we didn't store anything in Redis. So the average response time is around 2000 ms, and so is the non-login homepage. And then we try to store the timeline in the Redis, and we rerun the test. But at this time, the average response time is around 4,000 ms, which increased significantly. And the same thing happened to the non-login homepage. And then we try to cache the timeline and the like status in the Redis, and we change the client from 0 to 1000. And as we can see, at this time, the average response time is more than 7,000 ms, and the error rate is very high. So why does Redis make it slow? In the Redis, we store the timeline in such a way that the label is the user ID and the content is all tweets in that timeline. So it takes O of n time to find a single tweet, and we do this for every single tweet, so the total time will be O of n squared. And also, we have to know if I have liked the tweet, because it will display differently. So we have to do a Redis request for every single tweet for the like status. So it will take us extra O of n time. And at this point, we change the way we get the tweets. we get all the tweets of a timeline record one time, which changes from O of n squared time to O of n time. And we run the test, so we can see that the average response time is decreased. And also we did an experiment. We changed the timeout time of the loader from 10 seconds to 100 seconds. And as we can see, the error rate is 0, which means the only problem of our web application is that the response time is too slow, which inspires us to decrease the response time more. So then we change our algorithm so that we no longer get the like status. So at this time, the average response time decreased more. And also, we cache the user information in Redis, because in the homepage, we have to get the information of a single user every time. So if we can cache the user information, we can load the web page more fast. So after all the things we did, we decreased the average response time from 7,000 ms to less than 2,000 ms. And that is basically what we do to improve the scalability problem.